Hello. So if you're seeing this, then I have correctly used my phone and a box, and my phone taped to the box to record a video because I don't have my document camera at home. But I wanted to make sure that y'all had a chance to stay in the same place as the other sections. So I just want to go over what you're going to do with the lab. So everyone should be on page 4 of the lab. We're going to use the data from page 3 to draw the sun paths on this diagram, and then we're going to go into the white notes pack and we're going to draw all the sun paths on the same page here. So like the directions said, make sure that you have a red colored pencil, a green colored pencil, a blue colored pencil, and a regular pencil to do this. So I went onto the website and I got the data. So we're going to take the noon sun altitude from all 4 dates and we're going to record it right here. So in June, the noon sun altitude is 72 degrees. In September and March, rounded to the whole number, it's 49 degrees. And in December, the noon sun altitude is 26 degrees. All right. On each of these domes, we're going to mark, I put a dot at that altitude above the southern horizon, because when we look at the noon sun, because we live north of the Tropic of Cancer, we always have to look south. So if we go to this is you, and you're looking to the south, and if you look 72 degrees above the southern horizon, and that right there is solar noon. All right, and then over here, well, we don't know what south is, but it's the same as the other dome, so we're just going to put in east-west. So east is in the foreground, west is in the background. South is to the left, north is to the right, and we're going to make a dot at 49 degrees altitude, and this is solar noon. And now you can hear why I'm not there today, because I have a cold now on top of what I already had. Okay, so let's mark north, south, east, west on this dome. And for December, the noon sun is 26 degrees above the southern horizon. So we're just going to come over here. We're going to make a dot at 26 degrees on our external protractor. And that is solar noon. All right, and then we'll do the same thing over here for March 20th. East is in the foreground. West is in the background. South is to the left. North is to the right. And it's going to be the same as above. It's going to be 49 degrees, which is right here. And that is solar noon. So now we know the highest point that the sun is going to reach in the sky in its trek from east to west. In order to draw a sun path, we need to know exactly where the sun rises and exactly where the sun sets. All right. So in June, the sun sets north of east, but a little bit closer to east. So it's northeast, but it's a little bit closer to east. So this is sunrise. And then where sunset is going to be, if you look here, east-west, see how there's a slight angle right here? There's like an angle there. We're going to kind of do the same angle. And this over here is going to be sunset. Okay, we're going to do that 3 more times. September 23rd and March 20th on the equinoxes, the sun rises due east and sets due west. Those are the only 2 days of the year where the sun rises exactly east and sets exactly west. So those 2 days are easy for sunrise and sunset because it's exactly east, or what we say is due east, and exactly west, or as we say, due west. So we're going to mark those in. Sunrise. Okay. Now for December, the sun rose south of east and set south of west. So south of east, a little bit closer to east, right over here, okay? This is sunrise. And then same thing, we're going to kind of follow this angle between east and west. We're going to kind of do that. And then that is going to be our point of sunset. Okay. So now what we have is we have 3 points for each sun path. So what we're going to do is we're going to play connect the dots, but we have to do it artistically because we're showing an arced path on a flat piece of paper. So I'm not an art teacher, but the easiest way to do this is to start with the December. Make sure you're on the December sun path because it's the shortest. So we're going to be connecting 3 points that are close together, okay? So just watch what I do. When I start at sunrise, I'm going to aim to end up just left of solar noon, and at the last second, I'm going to make a little curve like that, okay? And then I'm going to come down on the other side, and I'm going to make like a dashed line because it's in the back of the dome, right? It's like in the back of the dome. And I'm going to put the direction that the sun is moving. So it's up in the foreground and down in the background. And of course, these are the AM hours, and these over here are the PM hours. All right. So you don't want to make it arced out here or arced over there. You just want to kind of go up straight and then make an arc and then like an arc and then straight down. So everyone should be doing that right now. Okay. Now we're going to, if you need time, pause. Whoever's playing the video, just pause, okay? Now we're going to do the same one for the equinoxes. This is the second longest sun path, okay? A 12-hour sun path. So same thing. We're going to start at sunrise. I'm going to aim just to the left of solar noon and then curve it in at the last second. Boop. And then back down to the west. And that's our rising half, and this is our setting half. These are the AM hours, and these are the PM hours. All right, and then we're going to, that same sun path for September 23rd. So I'm going to go up, and I'm going to aim slightly to the left of solar noon, and then kick it in like that, and then... Okay, so that's the sun path there, AM before noon and PM afternoon, okay? Now, the hardest sun path to do is the June sun path because it's just so dang long. All right, so we're starting all the way back here. I'm going to get rid of that. Starting all the way back here in the north of east. We're going to go all the way over to the southern sky and then come all the way back to the northwest. It's a very long sun path. This long sun path gives us our 15 hours of daylight. So go up, 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 and turn, and then go down like that. There's our increasing altitude or decreasing altitude. These are the AM hours, and these are the PM hours. All right. After we're done with what we're doing, you should answer these 4 questions. Not right now, though. All right. So now what we're going to do is we are going to go into our white notes pack. Okay. This is period 3. This is my take home. We're going to draw all 3 sun paths on one page, so you can see the pattern. All right. So I have this. And I have this. Okay. All right. Actually, I'm going to do that. Okay. So everyone should be on the first page of the white notes pack. If you need to pause, go ahead. All right. We're going to draw all 3 on one. And this is you. This is you. Right? That's you. And you're going to be watching the sun rise, go to the southern sky at solar noon, and set. Okay. So we know in December, the sun rises south of east and sets south of west. Now, you see how east and west are kind of straight back? You're not putting these 2 dots at an angle. These 2 dots should be parallel to this dashed line. All right? And the same thing in the summer, we know that the sun rises. So this is summer sunrise. And this is summer sunset. And this due east and due west are fall and spring sunrise. And fall and spring sunset. Okay, and then over here, this is winter, sunrise. And this over here is winter, sunset. Okay, and we know that summer is 6:21, fall and spring 9:23 and 3:20, and winter is 12:21. Okay, all right, now we have to do the same thing. We have to put our noon sun altitudes on in the southern part of the sky. Okay, so winter was 29. Okay, fall and spring were, sorry, not 29. I'm trying to memorize this data and I shouldn't be. Winter, sorry, 26. Sorry, 26. Fall and spring were 49. And summer was 72. Now, to make sure that we're connecting the right dots, this is what we're going to do. We are going to make winter blue. Okay, so we use a blue colored pencil. I don't have a blue colored pencil, but I have a blue pen. So winter is blue, blue, blue. Okay. And spring and fall will make green. I did have this one. So this is green. It's a puke green, but it's green. Okay, green. And then the 49 altitude is green. And then summer, hot, 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 right? Summer is hot, hot, hot. So summer is red. Okay, so we'll make red here, and red here, and red there. Okay. All right. Okay, so now let's draw the short one first. Go back to pencil. Don't do this in colored pencil. Okay, so we're going to do winter. Again, I'm going to shoot just to the left and then curve it. So I'm going to aim for my finger. This is a little bit longer than the smaller diagrams. Okay. There's rising and setting. Now we're going to label the date, okay? This is 12/21, okay? And then fall and spring, I'm going to aim for there. Okay, there's rising and setting. And then this is 3:20 and 9:23. And the summer sun path is the hard one because it's so long. So the sun's rising north of east, going all the way to the southern sky for solar noon, and then setting all the way north of west, which is a very long path, which takes a very long time, which is why the number of hours of daylight are so darn long in the summer. Okay. So, now, what this is, these are the sun paths for our latitude, which is 41 degrees north. All right. Now, we're going to estimate, we're going to draw an estimate of today's sun path. So today is what? Today is, well, you're watching it. Today is the 27th of January. Okay. So January falls in between December and March. Now, we're not halfway. We're not halfway. As that's Groundhog Day. We are a little bit more than a third. So if I had to estimate where the sun rose this morning, it wouldn't be here. It would be a little bit closer to December, all right? And so it would go follow a parallel path, right? Go up to about here, and then it would set. I know it's going to set somewhere between here and here, so it's going to set right about here. So I'm going to make a dashed line down to there. Okay, and so what this path is, this is today's sun path, and that's on 1/27/25, all right? Because here's the thing, the 12/21 and the 6/21 sun paths are the extremes. This is the longest one, this is the shortest one. Every other sun path during the year falls somewhere in between these two extremes, all right? And this is the equinox sun path here. So every single sun path, every single sunrise falls between here and here. Every single sunset falls between there and there. And every single solar noon falls between there and there. All right, now there's something interesting that you should know. How many degrees are there between this solar noon and that solar noon? Subtract 49 minus 26. Yep, 23 degrees, because we rounded. Remember, we rounded? How many degrees in between here and here, in between fall and spring and summer? Well, that's 72 minus 49, and that is 23 degrees. I know we don't have a azimuth circle here, but how many degrees do you think are between here and here? And between here and here? It's not a trick question. It's 23 degrees. And why is that? It's the same value as Earth's axial tilt. Yeah. So one more thing. Okay. So the sun's here in the winter, and it's shining down on you. Using the blue, what is the length of your shadow at solar noon? It's pretty long, isn't it? Pretty long, right? Because the sun's very low in the sky. What about here? What is the length of your shadow at noon when the sun is higher in the sky? Yep, it is a little bit shorter. It's a medium shadow, right? And what is the length of your shadow at noon when the sun is really high in the sky? Okay, this shadow is extremely short. Okay, so the length of the shadow is determined by the altitude of the sun, and the direction of the shadow is determined by the compass direction that the sun is in. All right, so at this point now, you're at the same place as the other sections. So now you're going to answer those questions here, and you're at the same place as the other sections. All right, I'll hope to see you tomorrow. Hopefully I'll be feeling better. Okay, later, Gators.